Question 21. Jackson is trying to find the density in grams per centimetre cubed of a block of wood. The block of wood is in the shape of a cuboid. So he measures the length, width and height correct to the nearest millimetre. The mass is 1970 correct to the nearest 5 grams. By considering bounds, work out the density of the wood. Give your answer to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. So, the best way to approach this is to work out what the minimum density could be and what the maximum density could be, and then consider those two numbers and see what to give as an answer. I've got these three lengths here correct to the nearest millimetre. So I'm going to put here the lower bound and the upper bound of each one. So 13.2, the lowest it could have been is 13.15. If it was less than 13.15 centimetres, it would have rounded down to 13.1. As soon as you've written one bound, be it upper or lower correctly, you've got 1 mark. The upper bound would be 13.25. Now that does round to 13.3, but it's the first number that does, so we know that the length has to be shorter than this, so we use the upper bound as the maximum possible length. 16.0 would be 15.95 and 16.05. 21.7 would be 21.65 and 21.75. I'm now going to work out the maximum and minimum volume of this cuboid. I should have said at the start, to find the density, you do need to know the formula. The density of an object is mass over volume. There's a clue here because it gives you the units. Grams is mass divided by centimetres cubed, which is volume. So the lower bound, these three measurements, if I multiply them together, will give me the minimum volume. So let's take a look. So we do 13.15 times 15.95 times 21.65, and the minimum volume 4,540, and I'm going to include 4 decimal places here, 9251. I just feel I'm going to need some decimal places, so I carry forward little error. That's the minimum volume of this cuboid. As soon as you get the minimum volume, or even possibly the maximum volume, you've got the second mark. I'm going to work out now what the maximum volume would have been. So I'm going to multiply these three numbers together. So it's 13.25 times 16.05 times 21.75, and this time comes to 4,625.4093. So let's just stop for a second and just consider what I've done. This cuboid here has a maximum volume of 4,540.925 centimetres cubed. Sorry, a minimum volume of 4,540.9251 centimetres cubed, and a maximum volume of 4,625.4093 centimetres cubed. The actual volume will lie in between. They are the two extremes. Now I've got to look at the mass. So the mass is 1,970 grams. this has been measured correct to the nearest 5 grams. So its lower bound is 1,967.5 grams. Anything smaller than this would get rounded to 1,965 grams. And the upper bound is 1,972.5 grams. Again, that's the first value that wouldn't round to 1,970. That's the smallest number that rounds to 1,970 if you're rounding to the nearest 5. The upper is the first number that doesn't round. So now I'm actually going to start to work out some of the density, which don't forget is mass divided by volume. What I'm going to do is work at the maximum possible density I could have, which would be the biggest mass divided by the smallest volume. So the biggest mass possible is 1972.5. That's the heaviest, the greatest mass this cuboid could have had, divided by the smallest volume. This one here. 4,540.9251. This will give me the maximum possible density. So let's take a look at what we get. So we need 1972.5 divided by 4,540.9251. And we get 0.4344. I've just rounded this 8 up to go to 4 decimal places. Grams per centimeters cubed. So that's the maximum possible volume. When I get to this point, I have my third mark. I'm going to do the same, but I'm now going to try and get the minimum possible volume for density. So the minimum possible volume will be the lowest bound for the mass. I'm running out of room, so I'll squeeze it here. 1967.5 divided by the maximum volume, 4625.4093. And that's going to give me, trying to find a space where we can see it. So 1967.5 divided by 4625.4093. And this one comes to 0.4254 grams per centimeter cubed. Once I've reached this point and I've got the upper and lower bounds of the density, I have 4 marks. And what we have to do now is actually give an answer, because the question said give your by considering bounds, work at the density of the wood. If you look closely at these answers, if I round to 2 decimal places, I've got 0.43 and 0.42. This stays at 0.43 because the third number after the decimal place is 4, but yet this rounds to 0.43 because the third number is 5. So give your answer to a suitable degree of accuracy. So to get the 5th mark, we say to 2dp, both max and min density, so maximum and minimum density, is 0.43 grams per centimeter cubed. And we have our 5th mark. Well done if you've worked all the way through the paper. This was the last question, quite a difficult one, worth 5 marks, so it's worth taking 5 minutes to have a go at it. If you didn't know the formula, density is mass over volume. It's going to be really difficult to get any of these marks. And well done for attempting all the questions on the paper.